Chang here, and welcome to my channel. This is a skill building video series where we pick a specific skill and practice it so that when we encounter a problem that actually need that skill, we can solve it with ease. Let's begin. So for today's video, we're going to focus on solving system of equations with 3 variables. Now, in order to solve that, first and foremost, we have to eliminate one of the variables right off the bat. We can do that by combining the equations in different combination or order. So, for example, you can combine the first and second one, and then the first and third one, or you decide the first and third one, and then the second and third one. The combination itself is entirely up to you. The end result is that you're trying to eliminate one of the variables, and you're going to have 2 other equations, resulting equations, that have only 2 variables left. Now, after that, you solve it like you would normally solve a system of equation with 2 variables. You can use either the cancellation method or substitution method. That's entirely up to you. You will solve 2 variables in this case. That means each of those variables you now have a value. What you're going to do then is you're going to pick one of the 3 original equations, plug in the 2 variables that you solved, and then solve for the final variables. That's how you solve it. Let's practice. So for our first problem, we have x minus 2y minus 4z equals 4, minus 2x minus 2y minus 3z equals negative 7, and 3x plus 2y minus 6z equals 2. Our first step is to eliminate one of the variables. Well, when we look at this, just on a strategic point of view, we have a minus 2y, a minus 2y, and a plus 2y. So that's probably going to be the first one I want to eliminate. The reason is because I don't have to multiply back and forth to try to change what's in front of the variables to start canceling things out. This one is fairly simple. Now, I'm just going to combine the first and second one. Here we go. So this is a minus 2y, this is a minus 2y. So what I'm going to actually have to do is I'm going to have to subtract this whole thing. Okay, so it's basically like multiplying a negative 1 all throughout. Well, x minus a minus 2x, what is that? So that's going to be a plus 2x, so that's going to give me 3x. Negative 2y minus a minus 2y, which is what I'm hoping, cancels out, becomes 0. Gone, right? Negative 4z minus a minus 3z, so this is going to be positive, so that's going to be minus 1z, or just minus z. And this one right here is going to be 4 minus a minus 7, which is going to be adding 7, which is going to give me 11. That's our first equation right here. So let me just underline that so you can see it. Now, what I'm going to do next is I'm going to combine these guys right here, the second and third one. And this one I really like. Ignoring the whole negative sign, that was for the first one. The original second equation and third equation, we have a minus 2y and a plus 2y. So if I just add them straight down, those guys just cancel. So what do we have? Negative 2y, or 2x, negative 2x plus 3x is just going to give me x. This one's gone. This add together, negative 3z plus negative 6z is just going to be negative 9z. Or minus 9z, and then you add those guys, it's going to be negative 7, and 2 is what? Negative 5. And so here we go. We have 2 equations now. So from the original 3 equation, we have 2 equations, and we're going to solve it like a system of equations. So let me just bring this guy over here. It's going to be x minus 9z equals negative 5. There we go. All right, cool. Now, what can I do? Well, I want to eliminate one of the x or the z. I'll just use a cancellation. This is a 3. Let's just multiply all of this by, let's just say, negative 3. Poor choice of symbol. But this in the end is going to be what? Negative 3x. Negative is positive, plus 27z. Negative is positive, that's 15. There we go. All right, so I'm just going to add these guys straight down from here, this top one and this bottom one, which is the result of multiplying negative 3 on everything. So the x goes away, negative z plus 27z is what? 26z. And 11 plus 15 is 26. So z equals 1 after I divide 26 on both sides. All right, there we go. That's our first one. Z equals 1, so I can pick one of these 2 equations, plug in z, and figure out what x is. Let's just do this one because it looks easy. Z is 1, so that's going to be x is x minus 9 times 1 equals negative 5, and that's going to be x minus 9 equals negative 5. So plus 9, x is negative 4. Negative or positive? Positive 4. There we go. Positive 4. All right, so that's positive 4. Now we have z and we have x. What we're going to do is we're going to pick one of those and we're going to plug it in and then figure out the remaining variable, which is y. Well, let's see, which one is, they're all about the same. Let's just pick the first one. So we have 4 minus 2y minus 4 times z is 1 equals 4. Okay, well, 4 minus a 4, oh, they cancel out, right? 4 minus 4, yeah, they cancel out. So those guys become 0. So then we have a minus 2y equals 4 divided by minus 2y, or minus 2. And then you have y equals negative 2. So there we have it. We have x equals 4, y equals negative 2, and z equals 1. So this is a long process. So system of equations with 3 variable sucks. But when you got to solve it, this is the way you go about it. All right, so here's our second problem. We have x minus 5y plus 3z equals 4, negative x plus 2y plus 3z equals 5, and 2x minus 3y minus 4z equals negative 5. Now, looking at this, once again, eliminate one of the variables. I'm going to choose x because x is easy, at least for the first and second one. The second and third one, I just multiply everything by 2 and it will still go away pretty quickly. So let's just begin. Now, the first and second one, if I combine them, just adding them straight down, one is positive, one is negative, is great. So this one goes away, the x goes away. Negative 5y plus 2y is what? Negative 3y. 3z plus 3z is 6z, and 4 plus 5, 9. Okay, that's our first equation. Okay, now I'm going to combine the second and the third one. But here's the thing. Notice once again, I want to eliminate x, so I'm going to multiply everything by 2. So here we go. Let's just make sure you guys can see that. We're going to multiply this all by 2 as our second one. I'm just going to write it right here. It's going to be negative 2x plus 2 times 2 is 4, 4y plus 6z equals 10. Okay, so this one and this one, I'm going to add together and the x goes away. So negative 2x plus 2x, great, gone. 4y plus a negative 3y, that is y. So let's just write down here, y. And 6z plus a negative 4z is going to be what? 2z plus 2z equals, and 10 plus a negative 5 is just going to be 5. Okay, so our two equations that we actually want to work with is right here. This one and this one. All right, so what can we do? What can we do? Well, in this case, it looks like, I could choose to eliminate y or z if I want to do the cancellation method. I'll just choose y because I see a 3 right, a negative 3, so I'll just multiply everything by 3. So let's just multiply everything by 3. And that'll give me what? 3y plus 6z equals 15. All right, now I'm going to add it straight down. So negative 3y plus 3y, what is that? Nothing. It's gone. That's what we hope for. 6z plus 6z is 12z. And 9 plus 15 is 24. Divide by 12 on both sides. And z equals 2. Okay, great. That's one of them. Z equals 2. So I'm going to pick one of these guys, and then I'm going to plug it in and try to figure out what y is. Well, in this case, I can just use this original equation right here. Z is 2, so that's going to be, I'm just going to write it right here. We have y plus 2, and instead of z, it's going to be 2 again. 2 right here, because, well, z is 2, and that's going to be equals 5. Well, that can help us solve easily. Y plus 4 equals 5, subtract 4, subtract 4. Now you have y equals 1. Great. So we have two of them. We have y equals 1, z equals 2. Now, we just pick one of these three and figure out what x is. It only makes sense to do that when x is just right there. After you do it, combine it, get rid of it, everything's great. So what I'm going to do first is I'm going to erase this part so that we can actually have a little more room. All right, so let's see. X is going to be, well, x, we don't know yet. Minus 5 times y is going to be 1. Plus 3 times z, which is 2 here, equals 4. X minus 5 plus 6 equals 4. Negative 5 plus 6 is what? 1. So plus 1 equals 4. Subtract 1, subtract 1. This goes away. X equals 3. And there it is. X equals 3. Y equals 1 and z equals 2. Now, before I finish up this problem, just to let you know, if you're ever unsure, just plug in these three values in the original three equations and see if it checks out. If you plug it in and it equals 4, if you plug it in and it equals 5, and you plug it in and it equals negative 5, then you're good to go. For the remainder of the video, I'm going to refrain from giving explicit explanation. Hopefully you guys can follow along. I'm going to use this, however. Notation 1, notation 2, and notation 3, just to represent equation 1, 2, and 3 and what I'm doing with it exactly, so you guys can see what I'm combining. Well, let's begin. Thank you for watching this video on solving system of equations with 3 variables. See you in the next one.